And also, again, before we get started, a huge thanks to our top tier sponsor, Indo. Storm windows on the inside, yes, we can have those. That's improved window performance with window inserts. You can feel warmer in the winter, cooler in the summer, while saving up to 20% potentially on energy bills. Third-party studies show up to a 10% reduction in air leakage too for whole home window upgrades. The do-it-yourself inserts are made of an acrylic panel soft edge with a soft patented silicone compression tube that presses right into the interior window frame from the seal to the draft. Check them out over at indowindows.com. And also thanks to our second tier sponsor, Water Furnace. We're talking geothermal ground source heat pump, some of the most energy efficient way to heat and cool a house, as well as heat water. And it can potentially get you and your clients a 30% non-refundable tax credit through 2030 under the Inflation Reduction Act. So check them out over at Water Furnace. All right, well, welcome everyone to Drawdown at Home, Residential Building Emissions and Climate Solutions. This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team, the three of us here, and I will be your moderator today. I'm the education manager here, Brett Little. This course is approved for multiple continuing education units, including all 5 pillars of green under our certified green home professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. I'm super excited about this because I know when Drawdown first came out quite a number of years ago, I immediately picked the book up and read through it and took a lot of notes and read through it and referenced it since then. I was excited to have Drawdown, I believe, come speak at and be a part of our large US GBC West Michigan conference in 2019 and get to hear about what they were doing then. So it's always exciting to be learning more and engaging with the folks over at Project Drawdown. And so that's why, Amanda, I'm super excited to have you on to talk to us a little bit about what you all have going on there now and how that incorporates into residential housing. So Amanda, welcome, and please take it away.
Awesome. Thank you for inviting me. So hi, everyone. I'm Amanda Smith, and I'm located in Washington State in the US, in the beautiful Columbia River Gorge, not too far from Portland, Oregon. So thanks for dropping in what you're doing and where you're viewing from in the chat. My background, I was trained as a mechanical engineer. Some labels that I've identified with are energy modeler, data scientist, educator. I've been mostly a researcher in my career. So I've been an engineering professor. I've been a research scientist at a DOE national lab. I have a tiny bit of experience in consulting for commercial construction. And I've been at Project Drawdown for 6 months. So it's just been about half a year. And in that time, we've built out a new in-house science team. So that means we have scientific experts on staff to help get people good information about climate solutions. And I want to share with you this journey that I'm on, where I'm trying to connect the big picture of emissions, which is what Project Drawdown does, right? We educate people on climate change and on the solutions at the same time. But that's at a very high global level, right? And so now that we have some in-house science expertise in different disciplines, we're looking at going into more detail with that. So I'm trying to connect this global big picture with what happens in the building sector, because a lot of my work has been, focused on building energy modeling or focused on distributed energy systems that work with buildings, right? So when I start with the global big picture, to me, that actually makes the smaller picture of the building sector or even an individual building, it makes it look a little different. I have a new viewpoint on it. And so I hope that you can start to make connections through this presentation as well. Talking about how do we really make sense out of climate change and these global problems, and how do we think about it when our actions might be limited to one building or one part of a building or a campus. So you'll understand what climate solutions we have, how to access them, hopefully how to think through that for yourself is something really a climate solution. And then I'll end with some resources for you. All this is in the slides. You have access to the slides if you're here. Great. So I want to start with some of the received wisdom about buildings and the construction industry and their emissions. And so my question is like, what are buildings responsible for? And we probably have all seen really similar numbers. Generally, people tend to land at about 40%. This has been true over the decade plus that I've been in research. So for example, the World Economic Forum says buildings and construction together account for 39% of energy related, they say 39% of global greenhouse gas emissions. What that is actually is 39% of energy related carbon dioxide emissions, right? Including upstream power generation. Okay, that's a very different thing when you actually are aware of the global perspective and where emissions come from. Okay, and their data, if you kind of click through, comes from Global ABC, the Global Alliance for Building and Construction's status report in 2017. So that's a joint effort between IEA and the UN. Let's look at one more example. So a lot of you I know are architects. Architecture 2030 says the built environment generates 40% of annual global CO2 emissions. Okay, and so they're talking about building operations, the construction industry, right? And the industry that's providing us with the materials for buildings. Their data also comes from the Global ABC report. They're just from 2018. And they say they also use some US EIA data, but it's not specified which one. Okay, lest you think that I'm just picking on these big organizations and asking for a ridiculous amount of detail, I want to point out I've done this too. So this is one of my research papers. And we said the main greenhouse gas contributing sectors in the US are transportation, industrial, residential, and commercial buildings, with the building sector contributing to more than 40% of total CO2 emissions. Okay, that is true for the US. Those are the main ones for us, but it does vary depending on what country you're in and how people are using the land. Okay, so if we consider all of those, what happens is residential, commercial together about 40.5%, according to the US Energy Information Administration's accounting. And this data was pulled from an annual energy review conducted in 2011. So probably should have updated that source as well too. Okay, so we keep hearing buildings are responsible for about 40% of emissions, but people are actually cutting up different pies and they're grouping up different things to make the building slice when they say that. Okay, so what I want to talk to you is the pie and the slice and the connections to the other slices. Okay, let's begin though by making sure that we're grounded in the same basic understanding of the relationship between emissions and the climate. And then what follows, I'm going to present, comes from our Climate Solutions 101 course, as well as our recently released Drawdown roadmap, and you'll have links to all of that at the end. So looking at the big picture is where I start, even though it's not specific to buildings or even to the particular homes you're working on, because for me, it actually helped to make sense of the situation and start thinking about what we can or should do across the building sector when I had this big picture perspective. And it's actually a little bit simpler when we look at it at that level. Okay, so we're zoomed in, we're looking at the built environment. My job title is Senior Scientist for the Built Environment. I just want to acknowledge that's a distinction that we chose to make, right? The built environment, of course, is set within all kinds of environments that we call natural environments, and they're deeply interlinked. If you take anything away, it's that they're deeply interlinked, and there's no magic one bullet climate solution. What we need is a suite of them. And so I'll use terms like nature, right? Built environment. Just wanted to acknowledge this. This is actually all part of a bigger picture. Okay, so I work at Project Drawdown. So I just want to clarify, drawdown refers to a future point in time when the levels of greenhouse gases in the atmosphere have stopped climbing and started to steadily decline. Okay, this is a critical turning point for life on Earth. So wherever that derivative goes to zero, we're calling that drawdown. That's the time when we stop making climate change worse. There's no time axis. When that happens is up to us. Okay, so our mission at Project Drawdown is to help the world get there as quickly, safely, and equitably as possible. And I'll give you the basic framing for how we think about this, and I'll clarify the big picture goal. Okay, so everything that's shown in black background slides, we're talking about the big picture, we're talking about the globe. And then what I present that follows, we've converted everything to CO2 equivalent because we need to talk about different gases, and we'll get into like what the main ones are that you should be thinking about. That's done on a 100-year global warming potential basis. That's not necessarily the time frame that we need to be thinking in, okay, but this is how the global emissions data is generally provided in a way that allows us to do that, okay? So if you're not familiar with that, we'll talk about it a little more when we get to specific gases, but I also think this is a pretty good explainer, especially if you come from an engineering background. It's pretty easy to pick up the concept. We want to get an apples to apples comparison, right? Okay, so let's think about achieving drawdown. What I'm really talking about is the atmosphere, the greenhouse gases that we're putting into the atmosphere every year. On the left side, we see where these gases come from. These are the sources of heat trapping gases, of greenhouse gases, and they're divided into all these sectors. They're global numbers because like ultimately we all share the same atmosphere. And so the numbers for each particular region will look different. Now, the emissions here, and this is how global scientists do it, are attributed based on where the gas enters the environment. That's the idea. They're not perfect about it, okay, but that's the idea, which I think makes sense. If you were going to take a global inventory to prevent double counting, I think the most straightforward way is to worry about where things are emitted. So when I first saw this graph, right, I think, well, buildings are very important in terms of climate change and global emissions. Why is this only 6%? Okay, that's why. We're talking about direct emissions. So these are things that are almost entirely burning fossil fuels, right, at the building site. Okay, but I just want to acknowledge buildings are a huge consumer of electricity. About half the electricity we consume or more goes to our buildings. They're where we're purchasing and preparing food and where we're collecting food waste. Many of the highly emitting industrial processes happen because we're making materials for buildings. Transporting people usually means getting them between one building and another, and transportation options also depend on what infrastructure and what buildings we have. And other energy-related emissions is this catch-all category, but really what it captures is emissions that are linked to fossil fuels before they get to the point where they're being used. So before, say you have fossil gas being delivered to your building, right? Before it got there, there's a whole slew of places that emissions can happen. A lot of places that methane's being released that's tied into that system. Okay, so those show up here. Thankfully, that's not the end of the story. So nature is actually doing us a favor right now and removing part of that. The lands and oceans are removing about 40% of what we're putting in year over year. We call these natural carbon sinks. So these are the most valuable sinks that we have right now. That doesn't necessarily mean that they're going to continue at this rate, right? At this 40% rate, depends on how much is in the atmosphere and how healthy those sinks are. So that's why part of our work, a lot of our work, right, actually relates to sinks and land use. Okay, but the key thing to know is that almost 60% of them get left behind. That's the problem, right? That's where it's creating this thick blanket of heat trapping gases. So we want to know, where do they come from? Where are they ultimately ending up? And find a suite of climate solutions that help us get those levels to stop climbing. So if we think about our emissions trajectory, right? These are emissions happening now, again, on a like gigaton of CO2 equivalent basis. We could keep following along the same trajectory. If you're here, I'm sure you agree that we shouldn't. Okay, but the plan, according to the scientists, the atmospheric scientists, the people who, have really tried to draw out a roadmap globally for what needs to happen, is that we need to take drastic action in this decade with readily available solutions that cut greenhouse gases. Okay, and so we have tons of research around what those are. So those are really big cuts, but we do have solutions to get us here. It's totally possible. Okay, we keep cutting in the next decade, but the biggest cuts have happened now, which I think makes sense with energy efficiency as well, right? Your first few energy efficiency measures get you the most bang for your buck. And we keep going until mid-century. So at that point, the idea is we have very few sources of greenhouse gas emissions left. We have this whole suite of solutions. We've done this guided by science. We've worked fast. We've worked for equity. And emissions are very, very, very small. Most people agree they're not going to be zero. Okay. So what if we're not all the way to zero? Like, what happens then? Well, the idea is, can we somehow bring the atmosphere back into balance by working to remove a very small amount of remaining emissions? If we look at carbon removal technology right now, you can't even see it. Okay, if we scale that up in the future, that'll partly be new engineered solutions. A lot of it will be helping nature's sinks, right, to be healthier and work more for us. So if we remove this small amount of emissions, then what happens is the planet hits net zero. So this is net zero. This is what net zero is. It means, right, we've equaled out so that ultimately the blue line's going down to zero. That's the point we need to meet and pass. Okay, net zero is what happens when we reach the point of drawdown. So that only works with steep reductions in emissions starting right now. Part of the reason for that I want to talk to you about is called the time value of emissions. Or you may also, if you see John Foley, who set up the slides that are going to follow, who's our executive director, and you see him talk, he'll call it the time value of carbon. So any guesses? Let's just look in the chat. Why did I use this image? Anybody have any thoughts about why I might be posting a volleyball picture? It is a pun, if that helps the engineers. Okay, I'm not seeing anything. The reason I chose this is because in the buildings industry, a lot of times what you'll hear about now is a carbon spike, right? Because the process of constructing a building or doing a major renovation, right, has a big spike of carbon emissions associated with that action right there. Okay, so let's go back to our graph and see kind of a visual for what that looks like. We're thinking about, again, emissions, net emissions, emissions and removal, and right, net emissions being where those two things meet, where the sources and the sinks balance out. But if we look at what we're doing over time, what happens is that when we add a carbon removal project and we do the drastic cuts now, we get those benefits all the way out to 2050, right? Huge. So we're preventing a whole bunch of carbon. So it's like the reverse of the idea of you want to invest early, right? We want to not build these up early. So that's part of why we need the big cuts to happen now. Okay, we keep cutting, of course, and that's also preventing emissions. And finally, we get to a point, right, where we've made huge cuts. And ultimately, the idea is over 90% of them, right, in this graph, we're showing 94% being emissions cuts, and 6% being carbon being removed from the atmosphere. And this is on a global scale, yes, but I actually think this is a ratio that we can hit in the built environment. And I think residences are a great place to start, probably the best place to start. Okay, so one more thing, I mentioned there are different greenhouse gases. I just want to point out of what the major contributing gases are, because we so often say carbon when we mean greenhouse gases, that it's easy to forget that even if we got rid of all of our CO2 emissions from fossil fuels, that's the majority of the problem, right? But that doesn't get us to drawdown. It doesn't get us to a global net zero. So CO2, yes, is the big one. Methane is also a huge contributor. We'll talk about why in just a second. Nitrous oxide, yes, is a combustion byproduct, but That's not a major greenhouse gas that we're concerned about in this sector. We should be concerned about F gases. So that's refrigerants, right? It just means fluorinated gases. Their fantastic thermodynamic properties are part of what makes them really good at trapping heat in the atmosphere. Okay, so let's dig in a little bit more on residential building emissions. Okay, what's the residential piece of that? So again, if we start looking at what the greenhouse gases are, the big one that we are contributing the most in proportion to the global distribution is CO2. And whenever we're normalizing, we normalize to CO2 equivalent. That means CO2 always has a global warming potential of 1. So that's telling you something about the physics of how it traps heat in the atmosphere, right? That's how scientists kind of gauge one gas versus another. We always start with carbon dioxide, and no matter what time frame we're looking at, it's always 1 because it is actually the thing that we're normalizing against. I have some exposed concrete shown in the picture because that's a big area where that carbon spike comes from, right? Okay, the second one that I want us to be aware of is methane. So methane is, basically the main component of natural gas. And you might have seen that there are methane numbers that are drastically different on different timescales. And so we have kind of some political considerations around policy where people are saying, well, we should be using the global warming potential over 20 years versus over 100 years. What that means is, if I look at the 100-year normalization, the one that we most commonly see, what I'm saying is, in 100 years, methane is likely to have this amount of global warming effect compared to what carbon dioxide would do in 100 years. Okay, what happens though is that methane actually does its damage kind of upfront and quickly and then decays. Like it doesn't stay in the CH4 form for those 100 years in the way that carbon dioxide does. And so if we look at it on a shorter basis, right, and then compare against CO2, we see much larger numbers for the contribution of methane. So methane is a really big deal regardless, right? But when we realize that we need to be making these steep emissions cuts within the next decade, methane becomes even a bigger proportion of what we need to do and what we need to attack and cut first. Okay, and then the last one, which I'm really worried about, which is a big slice, a small slice, sorry, of the global picture, but is a big part of where we have been contributing and where we could be doing better in the future, is around fluorinated gases or refrigerants, right? And so if we look at just kind of the range of refrigerants, we started out actually with refrigerants that were tens of thousands of times, some of them more potent than CO2. We've phased those out, okay? And some of these will be phased out as well, but we see a huge range. And we're talking about like hundreds of times more powerful than CO2 per molecule, right? So this is why new refrigerants, natural refrigerants, being careful refrigerants are a really big deal. So if you use CO2 as a refrigerant, then of course its global warming potential is always going to be 1. If you use propane, that's really friendly. But it's an entirely different gas, right? We have entirely new concerns when we introduce propane, right? Okay. So again, we're talking about net zero emissions. It's ultimately an equal sign. All of the emissions released by human activities get counterbalanced by removing carbon from the atmosphere. And this was originally a planetary concept. It is a planetary concept. I think that's where it makes sense. And so it can be a little confusing to quantify when we go below the planetary level. And a lot of the difficulty is, what is my removing carbon from the atmosphere piece of this? So if I count something as carbon removal or as an emission offset, right, then there's actually very limited ways to do that with the building itself, right? So we can put timber in the building, right, to kind of block away that carbon. And if it was managed renewably, That whole forest, it sequesters those emissions, right? And your building can ultimately act as a sink, and there are people doing really cool work so that we can figure out more ways to do this, or revive old ways of doing this that were carbon sequestering. But our options are much, much, much more right now with existing technology on the cutting the emissions sources side. So the big goal, driving down emissions dramatically on the left side of that rainbow, right? Making sure the very small amount of emissions are remaining. And if my building contributes to a global net zero, then its contribution should be measured in how much it cuts actual sources of emissions and how much carbon it removes from the atmosphere. Okay, so I said Project Drawdown is all about climate solutions. I said I wanted to come here and talk about climate solutions. Let's look at what can we do within this green home community about the planetary problems we've talked about. So let's kind of zoom into the building sector and think about residential buildings where we can get rid of the current sources of emissions. Okay. Within the building sector, remember, these are direct emissions, right? These are burning stuff at the building primarily. Those are emissions we know how to get rid of, right? We could wipe out this whole slice. I would love to be presenting this to you a few years from now and say, like, we did it. This is a negligible piece, because we do know how to do that. And when we do that, we're also getting rid of a huge portion of these other energy related emissions, right? Because a lot of them are tied to the oil and gas sector. We have to shut down that sector carefully, right? We still have a lot of infrastructure and assets to take care of, but stopping the demand for those fossil fuels, right, also helps directly with these other energy related emissions, which are a big piece of the pie globally. Okay, the other two areas where I think we have really, really big opportunities are in industry. This is the discussion around embodied carbon, right, which we'll get into shortly. Just the idea that the stuff that goes into a building mostly wasn't farmed, right? It came through some material process and I bought it from industry. And a huge portion of what the heavily emitting industries are making is going to the construction sector. So either for buildings or infrastructure. This is a huge opportunity for us. The other place, of course, that we can have a big effect is in the electricity sector. So if we're removing combustion from the site, we're shifting, right, into electrification, and we're talking about the buildings have an impact on the electrical grid. The building's primary energy usually is going to come from electricity. And so finding these clean forms of electricity and finding the right way to get clean electricity, whether it's distributed energy, whether it's utility scale, some combination of those, is really, really important and a place where we can play a big role. Okay, the other sectors, of course, are important. If you happen to be like a residential developer, you have a great opportunity to influence transportation. We'll talk a little bit about how later on. And then food, ag, and land use. When we look at residential buildings, right, on a land use, global land use scale, they're actually a very, very small portion of the area that we're looking at, right, in terms of the built environment. Okay. But we have a lot of opportunities within the way that we're doing things in buildings to also influence that sector. But it's not the primary one that I'm thinking about when I think about our opportunities. It's really first, stop burning stuff in buildings, right? And then look at your embodied carbon, help drive those industry emissions down, and pay attention to how you're interacting with the electrical grid. Okay, so on the sink side, I mentioned right now, with current technology and practices, we have limited ability to serve as a carbon sink. So sustainably managed timber could be one of them, and that's really well suited to residential buildings in a lot of ways. I did check in with a colleague who's, trained as an ecologist and works on living buildings and landscape architecture and that kind of thing. And wanted to get her input on what should I share with them about land use, about carbon sinks. And her advice was just don't build anything on an intact ecosystem, right? So be really respectful of the ecosystem that's there. If you're looking for new builds, right, watch out for old trees, wetlands, things that are really, really effective carbon sinks. Let's respect that and let them do their thing. Okay. So speaking of land sinks, I wanted to just take a brief pause. This is my personal favorite land sink. So it's a image that I took about 4 years ago in California in the redwoods. So this would be a tree that's not a good idea that we cut them down, right, to make building products. And I just think it's such a gorgeous, beautiful thing to support. And it's why a lot of us I know that work in green buildings are here, is because we really love the stuff that happens outside of buildings. Okay. So your contribution to net zero, again, is only as good as it cuts sources or helps sinks, right? Trying to help them through carbon offsets is understandable, but that's a really dangerous practice. It's really hard to do because of the way that those kind of offsets are managed. It's much better to think about, what am I actually doing to cut emissions, and supporting other people who are cutting emissions in the residential sector as well. So let's not get target fixation. That's my point here. Okay, by target fixation, I mean net zero buildings are very cool. We'll look at later some of the things that have emerged from the net zero buildings community that are really, really useful in terms of cutting emissions. But if we only focus on that, right? If I'm trying to make this building net zero, and I'm forgetting the bigger picture, it might leave out opportunities that we can see when we have the bigger picture. So the goal is not for every individual building in here to be net zero and balanced on its own, because they all have really different needs, right? We have really small structures, mid-rises, high-rises, and buildings that are serving all kinds of different functions. We want to look at what's happening across the sector, and we want to keep the bigger picture in mind and make sure that we're contributing to the global net zero by cutting sources. Okay, so I have a piece on this that's linked at the end if you want to kind of get into net zero a little more as well. So I want to shift to, not really shift, I want to just continue talking about how are we going to affect these other sector emissions that are happening because of what we're doing when we build, when we renovate in the building sector. So previously, and for, the vast majority of my career, operational carbon has been the concern, right? So a lot of my work is on reducing operational energy use in commercial buildings. And we've assumed that the energy, let's just say the overall operations are the key contributor for emissions for any individual building, and that they're the big picture. And what's been happening in the past few years is that, unless you're one who's really been working on this for a long time, and I really want to respect the people doing that who have been pointing this out and helped us get to this point, we're suddenly seeing like, hey, you can't zoom in on the operational picture. We really need you to look at this whole building life cycle perspective and to look at embodied carbon, which really means embodied greenhouse gases, just meaning we have a bunch of greenhouse gases associated with everything that we're doing. And when we say make a major renovation, we're investing, right, all of the greenhouse gases associated with, say, manufacturing that concrete or insulation or whatever you're using. We're investing that to make energy savings in the future. Okay. So when I say whole building life cycle, this is probably familiar to a lot of people in this community, but just wanted to make sure that you have the picture in front of you. And that I point out, this is where we were focusing, right, is on the operational parts of the building's life cycle, most of us. And this is mostly what we're talking about when we're attacking embodied carbon emissions, okay, is mostly the upfront emissions. I think that makes sense on two levels, right? So we actually have the best data here. It's something that's trackable, right? I can't track the end of a life cycle for building I'm building now. I have to make assumptions about that. We now have PDs, environmental product declarations, a lot of effort to actually follow out the supply chain and give us better information on the front end. And the front end is what's important. Remember, we've got to make drastic emissions cuts in this decade. So the ones that are happening, whoever's out there manufacturing something that you're going to use in your building for your energy efficiency retrofit, right? Those are the emissions that we really need to be concerned about. Okay, so there are whole building life cycle analyses that cover all of these stages. Absolutely. A lot of the work on embodied carbon is focused on this like A1 to A3 because it's where we have the most information and it's very, very important. Okay, so we have been assuming this is a small part for conventional buildings. I just want to point out, we assumed that correctly. We assumed it was like 10% or less of the building's overall life cycle. In this case, it's energy consumption, emissions. Emissions pie looks somewhat similar. Right, and so we have been assuming that, but then what we realize is that the tighter you make your energy standard, or the more advanced you make your energy standard, the more of that building's emissions tend to be embodied emissions. And that makes sense, right? If I'm building a passive house, if I'm building a ultra low, hardly using any energy building, then of course its operational emissions are going to be very small. And as a piece of the pie for that building, embodied emissions are going to be the bulk of it. That's fine. That's great. Okay, what I just found recently is a pretty cool paper that helps us, sorry, I'm delayed with my highlights, that helps us look at what are emissions doing as our buildings and our standards advance. And they actually have tons of, like hundreds of buildings across the world. The sample is definitely European biased, but there are North American buildings, a lot of Asian buildings. And they started comparing these life cycle analyses to look at what are emissions doing as our energy standards advance. And so if we look here, the whole bar is emissions and the dotted line is the share of emissions that are embodied, right? So let's look at residential. That's this part over here on the right. And just to clarify, the existing standard means that the buildings were constructed before we kind of tightened up or really made energy codes a thing. It's the majority of our building stock. New standards just mean we're going with the standard that's like a modern energy standard. So in residential for the US, that would be about the year 2009. And they went jurisdiction by jurisdiction or, looked at groups of countries together and set a cutoff year for when they would consider this to be new energy standards. New advanced lumps together the things like passive houses, ultra low energy buildings, net zero energy, net zero emission buildings that we saw in the previous slide. And so what we're seeing is that the whole bar represents the emissions of residential buildings, right? And the dotted line is the share of emissions that are embodied. So again, I think this makes sense. We see emissions going down with better and better standards, but we see that embodied takes up a bigger part, particularly when we look at the advanced standards. So if you're doing really good work on operational energy, if you're killing it there, the next thing for you to look at is embodied energy. Okay, you should look at both for sure, whatever you're doing. I'm just saying, if you're doing extremely well in operational carbon, be aware that that has the potential, it's not necessarily, but it has the potential, right, to also drive embodied carbon. So let's look at them in actual numbers, right? If I look at the operational carbon from the existing standard, we start here. And then if I look at the operational carbon from the advanced standard, it behaves as expected, I think. The numbers go down. The range actually goes down, so we're a little bit better able to predict. And I think all of that makes sense. That's what we're trying to do. So fine, the message is those advanced standards are working. And we see that across the globe in tons of different jurisdictions, tons of different climate zones. But let's look at embodied carbon. So we start with an existing standard and we try to quantify like, what is the embodied carbon associated with those residential buildings? We start here. And when we look at the advanced standards, we see a couple of things. One is that it's higher, right? On an ultimate basis, not on a percentage basis. On an ultimate basis, we're seeing higher numbers. We're also seeing, I think this is really important, a higher range. We're seeing a higher possible range of values. And this is global data, but I actually saw Chris Magwood, who I believe has presented in this series before, talk yesterday on LinkedIn about a study they did in Canada where they were looking at all of the varieties of possible embodied emission values across actual builders. And so they also saw within this particular study, which was in the same general area, a huge range of possible embodied emissions values for these projects, whether they were high performance or not. So to me, this is like such a great place for us to start focusing and seeing opportunity, is that we know that there's a huge range of potential values. So we want to start exploring like, what's available in my location? How can I do better? Can I learn from the buildings that are getting these really low values on embodied carbon and do what they're doing? And the big things to look at in residential are concrete and insulation. So these are the products that you're getting in to have really high carbon emission or greenhouse gas emission footprints. Okay, let's do more solutions. Let's do particular solutions. When I tried to plot out this talk, I plotted out all the things that I wanted to tell you and all the solutions we've grouped up that I thought would fit. Obviously for time, that's not realistic. So really what I want to point out to you is one per sector. And I want to give you kind of a sectoral picture. And then this gives you a sense of how to navigate our solutions. We have what's called a solutions library on our website. And within each solution, when you click through, you can also find what are the actions I can take. And we're starting to get more information on what are the what's called co-benefits, which are really the benefits in residential, meaning better air quality, it's healthier, things are more enjoyable, society works better, like all of the good things that we really want, because we understand that no one cares what the actual number of the global mean temperature is. Okay, so we'll start at home in the building sector. And when we break it apart globally, we see that this is the split between commercial and residential buildings. In the US, it's much more heavily weighted towards commercial. Big opportunity here, refrigerant management. This is a big opportunity for us to deploy a climate solution, right? We're gonna need more air conditioning because of climate change. And we're also deploying heat pumps as a climate solution. And with that, we've associated a lot of refrigerant. And if you're using any refrigerant that has more of a global warming potential than CO2, it's a really big deal that doesn't make it out into the atmosphere. So the big ways to do this, right, are lower the demand, lower the use of these kind of appliances, replace the refrigerants with low global warming potential refrigerants. So you can ask for low GWP options, increasing efficiency when you are doing refrigeration, controlling leakage, and ensuring recovery and reclamation and proper destruction. You can check the US EPA if you're in the US for how to do that at the end of life. Okay, and then one that I think may resonate with this community is, I saw Nate Adams, who does a lot of education, right, on electrifying and on healthy homes, post about how these self-installed heat pumps are kind of known within his community for leaking or for, being a case where a professional comes in and needs to fix what's been done and finds that it's actually not even charged with refrigerants because, the connections weren't set up in the right way, or somebody doesn't have a torque wrench. I don't know. This is where I think we have a huge opportunity to do a really good job with this and make the climate solution work. Okay, so I wanted to point that one out as my building sector piece. if we look at the whole sector together, the idea in the building sector is let's enhance the efficiency of everything that we're doing, right? Let's conserve first. Let's minimize whatever we can. Let's do it efficiently, and let's shift our energy sources to clean energy sources. Okay, and then if we go by like the other sectors in terms of their global contributions, the electric sector is about half sending electricity to buildings. So there's a huge opportunity for us. So I've tried to pick out a few things that you may not have thought of as climate solutions, or you may not have connected to this particular sector. So one that's interesting here is just using a cool roof, right? Green roofs probably don't reduce your cooling load as much as an actual white roof, right? But they provide a host of other benefits too. So I think they're a really cool choice if that's something that you want to do with your building. When we paint our roofs cool, helps reduce our cooling demand. Pretty simple thing to do. I think that one's pretty cool. Okay, in the electricity sector, the big ideas are shift production to clean energy sources and be efficient. So really similar, actually. Okay, food, ag, and land use. Like I said, we don't have as many opportunities as residential people to affect this sector. Well, as people, we do, certainly, eat more plants. But in terms of what you're doing in buildings, these are the things that we're watching out for, and these are the things that we're seeing globally are driving emissions coming from the land use sector. But one place where we do have an opportunity is to make sure that we're paying attention to forest protection. So if you are using wood products in your building, right, making sure that that's coming from a sustainably managed forest, not buying into things like bioenergy that claims to be renewable, but is either renewable on such a long time scale that it's not practical for us, or keeps us burning things at a building site when we don't want to be doing that for other reasons. Okay, so here's the big picture of the food, ag, and land use sector. A lot of it's food stuff. Okay, industry. This is one where I said I think we have such an opportunity, and we have so many people doing good work in this area. A lot of these things, particularly cement and metals, are coming to buildings, right? So the solution that's super useful for that is looking at alternative forms of cement. Of course, being efficient with cement, right? If you don't need it in a place that's non-structural. But absolutely, we're going to use cement in residential buildings. And so using it thoughtfully and looking for the lowest GWP alternative you can. Cement's really tough, actually, because, right, cement's going into concrete. And when we're forming the cement itself, that chemical process gives off CO2, and we're using a lot of heat. And so we tend to provide that heat with fossil fuels. So it's real easy, not real easy, it's real straightforward to cut down on those fossil fuels. Tinkering around with the cement mixes and making sure that that chemical process either doesn't emit as much CO2 or that CO2 is captured is a little trickier. There is also tons of really cool work going on in this sector. So I think that's a great place where we have a lot of opportunity to influence things. If we look at the industry sector, big picture, we see refrigerants being a big one that's getting attributed to the industry sector. And I would argue, right, a lot of those direct emissions are happening at a building. So we need to own this one, as well as trying to reduce waste and improve the materials that we're using. Okay, transport, again, mostly getting us from one building to another. A personal favorite is walkable cities. Because they actually benefit us socially, and walkable cities are generally much more bike friendly as well, but we also have a solution for bike friendly infrastructure. And that's one where if you're looking at, if you're a developer, if you're developing apartment buildings, something like that, providing the infrastructure so that people can bike, can take trains, do have cool things to walk to in the area is so much better for the people, for their health, for the societal health. And it's a great climate solution. Okay, so transportation sector, we see a big piece of it is shifting to alternatives from what we're doing now, which is, largely driving around in our private cars with fossil fuels. And then of course, being more efficient and focusing on vehicle electrification. Okay, so again, the other sector, a lot of that's emissions that happen because we're using fossil fuels. So flaring just means I'm trying to get rid of something and I burn it. Venting is worse actually, because if I'm sending methane straight onto the atmosphere, remember how potent methane is? Fugitive emissions mean, it wasn't by design, but they escaped. And that happens. It's a big piece of it. So everything that we can do to drive down the demand for fossil fuels, and also as citizens, just to speak up for responsibly decommissioning or changing that infrastructure that's having the methane leaks, is a really big piece of what we can do. So we don't actually count this as an industry sector solution, but I put it in there because I think that heat pumps are like the poster child for electrification right now, right? But electrification actually, in and of itself, attacks a big portion of the other energy emissions. Okay, so my big simple message for you is when we look at kind of the drawdown perspective, we have so much opportunity to improve society by making residential buildings better. And the things that you do to make residential buildings better, right? Understanding your control layers in the building envelope, providing adequate, filtered, balanced ventilation, all of these things that you do that are just building science excellence, I want to tell you those are climate solutions as well, because they make the buildings more enjoyable to be in. That's the thing that matters, is that we're actually taking care of people. And then if we look at like our big picture, we have so much opportunity in reducing sources, and all of the things that we're doing to reduce sources also are improving society along with it. Okay, so my vision is like, what if everyone had a home? What if we all got clean filtered air? What if we all didn't have fossil fuel infrastructure in the home so that we didn't have any pollution from fossil fuels or any risk of leaks? And what if they were beautiful and green as well? Wouldn't that be a good world to live in and a better home for all of us? So let's go build it. I got a few resources to point out that we can provide at Project Drawdown. As Brett mentioned, this book was really groundbreaking in pointing out, hey, we actually have enough proven climate solutions to deal with climate change. That was published in 2017. That was pretty revolutionary at the time. You can also get the update to that book for free. Sorry, there we go, which is the Drawdown review. So this slide is actually a link itself. You can get the PDF. It gives an up-to-date overview. It shows the big picture, the climate solutions by sector that I've been talking about. We update our solutions library on the website pretty frequently. So the idea is, right, we're using science to guide climate action, and you can look up individual solutions. Just be aware the distinction between the individual solutions can be arbitrary. We're trying to give you a collection, a great menu of those. And what the science team is moving into is, how do we make the connections between people who are doing what you're doing, people who are doing good work in very specific areas, right? How do we help connect them with the climate solutions that make the most sense given when it's happening, where it's happening, and what atmosphere, what country, region they're in. All right, I mentioned a lot of the materials came from our Climate Solutions 101 series, so you can see John break it down in more detail. You should also, after that, go and check out the Drawdown Roadmap, which is this key set of principles about how we should be using science to guide climate action and why the timing is so important. This is the piece that I mentioned that I wrote on net zero. And a really cool favorite thing is the Drawdown's neighborhood stories. They're little documentaries, really just storytelling. They're inspirational, they give you new ideas, and it's local people that are implementing climate solutions in all of the sectors in their areas. So at the end of this presentation, I have my picks for this community. So if you want to click through and watch particular stories, there's 4 of them that are just my favorites and I think are relevant to the stuff that we've been talking about here. So I'd love to hear from you. This is my information. You can find all of my social media presence, learn more about my research, all of that at this link. But I'm happy for you to email me, not just if you have questions, but if you have thoughts on what would help connect your work with what's on the cutting edge, what's practical in terms of climate solutions, if there's information or tools that would help you to find that and make the connection to climate solutions, I'd love to talk to you about that. Maybe it's something we can help with. Maybe I can direct you to someone else's work. So if you want to have input on kind of what is this roadmap for the residential buildings sector, or if you want to talk about the barriers that you're running into, be happy to talk with you more about that too. Let us know how we can support you. And I also just want to say thanks for the work that you're doing. And that's the end. I'm going to get a quick drink and let Brett tell me what questions have rolled.
Yeah, thank you so much, Amanda, for giving us all that background and your perspective. Real quick, before we get to those questions, as those questions are rolling in, just a reminder, yes, the answer in most cases is always yes. You can rewatch this session, share it with your colleagues, with your friends, share it online for all we care. Spread the word. You can access that on our YouTube channel. For those of you watching this in the future, not right now, but on demand, make sure to take that quiz with an 80% passing rate and you will receive your continuing education units. For those of you here today, make sure you check your spam for certs@gutenbergcerts.com. You'll receive your CEU certificates over the next couple days, and you can log that. And before we get into those questions that are coming in, I always have to say a huge thanks to our volunteers, our board of directors, our nearly 300 members who support our work, and our top tier sponsors, and all our sponsors, but especially our top tier sponsors who have these solutions to help you out: Mitsubishi for air source heat pumps, Rheem for air source heat pump water heaters, and all of our sponsors who allow us to do what we do. So Amanda, there were a bunch of questions, and I'm kind of gonna, and if one of you says, hey, you didn't get my question completely right, let me know, but I'm gonna summarize or merge a couple of them, because I think the question was the embodied carbon aspect from some of the charts and the data you were showing. When you were showing emissions, I think for buildings, the building sector, I know the first one really had to do with just direct immediate emissions, but was embodied carbon at all part of your emissions calculations that you were showing in any of the charts?
Yeah, so first of all, the charts, so the charts on the back background, right, are global emissions data. And the distinction is embodied emissions makes sense if we're looking at it from a building's perspective or from a residential building's perspective, right? Then embodied is talking about things that are happening in other sectors that we're driving from our actions in the building sector. So the global data doesn't include embodied emissions because the accounting method, right, is to try to track everything where it's happening and then apply it to a building sector, an industry sector, electricity sector, that sort of thing. Okay, so it doesn't actually make sense from the global perspective when you're trying to capture things the way that climate scientists do. When I presented the graphs in the white background, those were for the building sector. So that's not my work. I don't actually know the authors. I just think it was really cool work. So I wanted to share it with you because I think it gives us such a good perspective of what's happening and how that shift, right, is happening from operational carbon to embodied carbon. So of course, the ones that are labeled embodied carbon do contain embodied carbon. They aren't mine. I'm very thankful that that work is out there, and I hope that gives us a better picture of how things are changing and why embodied carbon is seemingly suddenly really important. Of course, it was important all along, right? But it's becoming a bigger and bigger piece of our pie, and we're having more and more options of how to deal with it. So yeah, on the global level, not embodied just because we'd be double counting all over the place. So we just try to track emissions where they happen at the global level.
So obviously, when it comes to operational versus embodied carbon, perhaps there are trade-offs, and that could be a trade-off maybe when you're building new, or perhaps there's, maybe put another way, perhaps there's perceived trade-offs. We'll just say one or the other, but you're building new and you have to make a decision to reduce operational carbon, but you might have to, or you might feel, or you might be lacking information where you have to then maybe make a decision instead to reduce embodied, but in the short term, increase operational. And of course, which one pays the bills, right? but or the trade-off, some of these, and I'm just merging these questions here together, but or the trade-off being in that, when is the time to retrofit, right? Because there are, you put in new windows or new insulation or new HVAC, they have an embodied impact where you could have just done nothing. So speak to us a little bit about what you're seeing or hearing in those trade-offs. I know we're not going to solve it here today, but I promise you all we're going to keep talking about this with other professionals. So not that you don't know the answer, man, or anything, but I just know it's a big question. So
yeah, it's a huge question, and I think it's an important one. So yeah, thanks. What we're seeing is that there's so much more data being publicized, being shared, and so much more attention to like looking at a holistic perspective of the life cycle of buildings. Mm-hmm. So one of the things I was really excited about was that this study was there, right? I cannot imagine the amount of work that they went through to find all these life cycle analysis studies for all of these buildings. And they talk about in the paper, they started out with like 700 or 800 and they wound up with like 300 that kind of met the criteria they were looking for, because they wanted things to be standard enough that it actually made sense to collect them together, right? And so if you do life cycle analysis, I think it's so valuable if you can share your data and share what you've learned. We're seeing that people are increasingly willing to do that. A lot of leadership's coming out of RMI, New Buildings Institute, Carbon Leadership Forum. They have tons of data for you, and tons of like big picture takeaways. So how do I think about that? Well, like, if you're looking at, maybe I want to retrofit my home, I'm not going to go and do that full like ISO standard LCA. So the way that I think about that is, I'm making a carbon investment. I'm making an investment of upfront greenhouse gas emissions. I know that for me to follow along with the planetary plan that keeps us the safest, the biggest emissions cuts have to happen in this next decade. Mm-hmm. So if I, am dramatically affecting my operational emissions immediately, that's great. If it's a smaller impact, right, in the short term, and I have a big investment of upfront carbon, then that becomes something that maybe is like less important or less prioritized to me. And the things that I would watch out for are like deep renovations, right? Needing new concrete, that's a big deal. Lots of insulation, if that insulation particularly is like a plastic. So like, EPS, like anything that's like polyiso something, right? Those are generally things that have really high embodied carbon emissions. I am not telling you don't insulate your home, right? If your home needs insulation, and especially if you've got the envelope open, like absolutely do that. You know what you're doing, and you know what you need to do to manage water and moisture as well, right? So make the best decisions for your building, understanding that building health and water management comes first, absolutely. But if I'm going to invest in something that's going to have a big upfront carbon hit, to me, I want to know that that's going to have a big impact in terms of carbon emissions in this decade. And for me, I also live in a place where we have a lot of hydro on the grid, right? So saving electricity, because my house is almost entirely electric, right, is not, to me, as urgent as it would be getting fossil fuels out of my house. So the way that I think about that is I'm making an investment. When is my payback? And I want to heavily discount payback that's decades in the future. I really want to focus on payback that happens soon. Windows you mentioned, right? Also glass has a lot of embodied emissions in it. You have to heat sand up quite a bit. But then generally for the residential sector, I don't think they're when we like look at the life cycle studies, we don't see that overall in that sector, they're as big of a deal as they are in, say, commercial, where you have these buildings that have like entire facades and they're like glass curtain wall, you know.
Thank you. So looking at that first, or maybe not the first chart, but the one that kind of boiled down to the direct emissions, you know, showing buildings at 6%, not very big. Would it be true that if we electrified essentially everything, that would actually go down to zero? Because there wouldn't be a direct emission then, correct? Am I missing something?
Yeah, no, that's exactly it. That's why I wanted to like frame that one with the circle and a slash through it, because I'm like, for us in this community, that's something we know how to do. We're on track to doing.
Right.
Like that should be our first place to stamp out emissions. Let's make the building sector disappear in the project drawdown graphs. Like, please help me do that. Yeah. Now, and electrifying is like almost entirely all of that.
Right. So the reason I kind of set that question up was to answer this next question, in that, you know, is that, of course, an illusion in that, and I say it in this way to give some people context, like people tell me, oh, I'm putting some solar on to get rid of my electric bill. I'm like, well, wait a minute. How do you heat your house? Oh, I use, you know, methane gas. Oh, well, you're barely denting your energy usage and your carbon emission. Oh, and the same idea, like the scaling it up, we go all electric. So the question here being, have then now we not just shifted the energy source to methane and coal, maybe oil in worst case scenarios in the Northeast now, and just created more emissions? Or is that a sort of case by case? Like, what are your thoughts there?
So let me untangle, because I'm like kind of sensing maybe two strands in there. The first one being like, if you're going for a net zero home or any sort of, you know, fancy standard, and you're driving down energy use and you're putting on solar panels and you're taking an annual energy total, this is what my piece on net zero energy kind of goes into more, is like, those things don't correlate directly to the larger reality of reducing climate emissions. And so if you're keeping, you know, if you're burning fossil fuels in your house for heating or hot water, whatever, that's the thing that needs to go. And I think that's a better investment in removing that from your home for a variety of reasons, in addition to climate, right? Before you kind of like slap on solar panels and call it good.
Right.
There's also the reality of how we interact with the electrical grid, right? And so if I have solar panels and they, over the course of a year, produce the net amount of energy that I'm using, I'm still like asking the grid to do things during the year. And the trick is, when I ask for energy, and depending on all the other conditions on the grid, I can make that like easier or harder for the grid to do its job. Okay. One of the other objections that people say is like, oh, well, if we're electrifying, we're shifting away from fossil fuels on site. Okay. But, you know, maybe I had a really efficient condensing boiler or something. And now I'm going and I'm going to ask for more electricity from the grid. And that electricity in my state is, you know, maybe we still have a coal plant, or maybe we have a lot of natural gas on the grid. Okay. What we see there is that if you do it right, meaning we pay attention to energy efficiency and home comfort, and we do that, and then we size the heat pump, and we get an efficient heat pump, backup resistance if you need it, sure, but heat pumps are super efficient. Then even looking at that whole big picture, we're still more efficient overall, right? Even asking for a little bit of electricity from a grid that's not decarbonized. The other thing to know is the grid is decarbonized. So if you look at like, there are projects at the National Renewable Energy Lab where they're trying to provide kind of emission factors for the grid going forward. Sorry, I'm US based, so I'm really going to heavily weight on this here, but we're decarbonizing around the world for sure. They have to keep taking their like most aggressive renewable scenario and like upping it, because we're actually doing it faster. And the key thing to know is we're in a time frame, right, where we need to have action in the next decade. And we're talking about residences where the time frame of our equipment is so much longer. And so if I replace natural gas with natural gas, I'm locking in that, you know, going forward, or else I'm going to cost myself a lot when I go to electrify. Sorry, I know it's not just natural gas heating versus heat pump, but that's kind of like the big one that a lot of people get stuck on. So I would say the grid is decarbonizing faster than you think. If you do it efficiently, you can still win. And you also have to think forward of like what's going to happen going forward.
Yeah, well, thank you for that. And I'll just share anecdotally, you know, we ran the numbers like on my own house here in Michigan on the MISO grid, very heavy on coal and natural gas, use the home energy score to run the numbers, which is fairly accurate. We found it to be very accurate. And we were able to look at, you know, being on gas systems versus being all electric, and absolutely in the modeling at least showed, you know, immediate carbon savings, even with our heavy coal and gas grid. And I can get those numbers down even more if I shift my energy use to later on in the day when the wind is typically blowing more. So, and we'll be doing more sessions on that kind of topic later, but just wanted to put that in there. So the last two questions that came in kind of together on the white roof piece that you had was, you know, first of all, how important is a white roof in the colder climate zones? They were mentioning 5, 6. We might have some 7, 8, 9ers here, maybe. I don't know. And you know, where do trees come into play for shading instead of white roofs as a solution? Is that discussed at all?
Awesome. Yeah. So white roofs in cold climate zones, I would say, just like as a blanket statement, aren't critical. Like where they really, really have value is when you're in a cooling load driven climate. And of course it depends on building geometry and all of that stuff too, right? But they can show like a pretty amazing benefit. And if it really is an option of like, if you have a flat rooftop, just an option of paint color, it's really cool. I have black shingles on my home. I'm in a pretty cold climate. It's fine. Yeah, green infrastructure. I love, there is some academic work going back, you know, like a couple decades or more even, on like, what are the benefits of shading? There are benefits for energy consumption. It depends on how you do it. I think the human benefits are actually a much bigger deal. And the like building science benefits, right? Because if you're controlling the light coming into your room, if you saw me this afternoon, like I need to put an overhang in, I can't work here in the afternoon, right? And I can't have vegetation right next to the house because we're in a forest. So I think it has so many other benefits that, like, to me, the climate is not the selling point, but I think green infrastructure is really valuable. And yes, there are, you know, studies that demonstrate kind of how you can see benefit from that shading. Yeah.
Well, Amanda, those are all the questions I'm seeing right now, but you know, where can people go to reach out, contact you, or learn more if they have other questions or want to, you know, learn more about Project Drawdown?
Yeah, you can email me, amanda.smith@drawdown.org. Please feel free to do that. And then if you click on this link tree, you'll see like my information, my staff page at Project Drawdown, my research work, all of my social media places. So if you want to see more things that I'm doing, you know, please check those out. And then please check out the Project Drawdown resources as well. And I'd love to hear from you. I'd love to have more of a dialogue with people in this community too.
Well, great. Amanda, thank you so much for your time. Thanks to Project Drawdown for having you out. Take care. Have a good rest of your week, everyone. We will catch you on the show next week. Thank you so much.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.